Ku parameter, or kurtosis, tells us something about the extremes of a surface. If I have just a random surface with peaks and valleys, perhaps this might be from grinding or just a set of statistical Gaussian random points, we will have a distribution of heights that looks something like our bell curve that we've been seeing before with other parameters. The bell curve is a known shape, and it has some amount of spread based on the Gaussian distribution of a few points at the edges and a lot of points in the middle. This surface has a strange property. It has a kurtosis. If this is a roughness profile, RKU would equal 3. So 3 is a normal distribution, and our kurtosis parameter tells us something about the extremes of the surface. So let's describe a surface with no real extremes, a surface that is perhaps a square wave. So here's our mean line. Let's make a square wave surface. This surface has a distribution that's rather unusual. The distribution of points in this case isn't a bell curve. In fact, all of the points are either right here or they are right here. So it's a strange curve of a spike right here and a spike right here, and this surface has a kurtosis of 1. So anything in between a square wave and a random surface would have a kurtosis somewhere between 1 and 3. For example, a triangle lives in this space. A triangular surface has a kurtosis of 1.8. But as surfaces get more extreme, let's say we're looking at something extremely plateaued or extremely spiky with perhaps coating nodules, those surfaces will have distributions that are very, very stretched. Now, in one case, the distribution is stretched upward. In another case, the distribution is stretched downward. Kurtosis doesn't know about the direction. It only knows if the distribution is stretched or if there are outliers, in other words. So we can have outliers up or down, and those outliers will cause kurtosis to go up. So in these cases, we might be looking at a kurtosis of perhaps 10 or 15. So kurtosis is a measure of unexpected things in our data. If the surface was random, like a Gaussian or bell-shaped curve distribution of heights, we'll have a kurtosis of 3. But if there are strange outliers happening either up or down, kurtosis will go up. In this example, perhaps it was 10, it could be 20 or 30, but the number is very, very noisy because individual outlying points will combine into this mathematically and cause a huge influence. So a surface that looks random but has one extremely bad point could still have a very high kurtosis. So kurtosis is one of those mathematical parameters. It's used in statistics, but we need to take special caution when we apply it to surface texture.